Hello, this is Professor Michael Abbasi. This is from my CIS 2808 Introduction to Computer Forensics course, and this is Topic 3, Understanding Hard Disks and File Systems. Of course, this is using the new CHFI material. This is a really big topic. It has a lot to encompass here. If we look at the module objectives for Module 3, which matches with our Topic 3 here, it's we look at logical structures of disks, understanding booting processes, looking at autopsy, sleuth kit. Definitely there's at least I believe three labs for this, and looking at hex editors, especially analyzing file formats with hex editors. Now there's a lot here, so I have a separate video, which is a recycled video. Should be posted here in this topic. It goes over the basics of hexadecimal. Hence hex or hex editors, or at least hexadecimal, and how that works. And then I have another video. It is also recycled. I think I took up the first minute and a little bit of the end. And it goes over really into detail about disk structures. So what I'm going to do here is just go over the highlights of what this CHFI Module 3 has. And I want to show you a couple examples of at least autopsy, and then of course hex editor and how it's useful. So anyways, when we look at this module here, there's a lot. I bookmarked some stuff. I'll probably fly through these a little fast. I want to leave a lot of this detail for the other videos and or for you to go and explore in the actual readings, and also the lab system. So but basically, again, you're going to see this poorly drawn by me in a different video to get more in detail, but understanding hard drives is an important concept here, and it should be something you've learned in other classes. Taking Linux, we go over hard drive partitioning. Windows classes probably going to this too. Understanding the basics of platter drives, and yes, they're still around, even though they're beginning to be less and less. I mean, still, I think for the value for storage, they're still around. And I'm not sure about the longevity, but just understand the hard drive architecture, specifically tracks, sectors, and clusters. That's probably the three biggest things there, and let you know how things are sort of partitioned out by the operating system. So this goes into sector information, what a 4K sector or 496 bytes looks like. This might be more common with NTFS, I believe. But also it can be common with any kind of Linux or Mac. Depends on how the sector is used. So capacity calculation is pretty important. You might need to look at this. This could be something you might need to do in a lab, or it could be something you might need to answer. It's something that you don't do too often, but understand how it works when you calculate the capacity. So again, we're looking at the total size, number of cylinders times number of heads times sectors per track times the bytes per sector. So in this case, you can see the math right there, gives you a total bytes. So that could be important to just to get the total architecture of a drive if you cannot get it for any other method. Now we'll sort of say this here and interject this. A lot of the stuff that's done for you is by tools. And we're going to look at several areas here. One, of course, is file mismatch is a huge one, file headers, and of course hard drive analysis. But it's important to come into this understanding how those tools work. Looking at previous topic, you might need to explain this in maybe a testimony. You might need to, explain it to a committee or somebody. Someone might have questions about how the tool works. How does it know that's the start of the sector? That's the total capacity size. So just keep that in mind. Now, a big one here, which I don't go over in the other video, the recycled video on hard drives. I think I mentioned it briefly, is SSDs. Usually becoming really more prevalent, even in enterprise. So again, there's no moving parts. So of course, as you probably know, SSDs are fantastic for performance, space size, power consumption. They got a lot of really a lot of bonuses there. So fast. So you can just if the cost was the downside, it's becoming less and less of an issue. So you might even run into these beforehand. So the thing to look at too is disk interfaces. PCI, yes, good old SCSI, and serial ATA, attached, serial attached ATA. There's just a few of them. Have a record of understanding how drives are attached. You go to IDE in case you went to an old system. It's very possible. So that's a good thing to go and look into, especially when you look at creating a copy of an external hard disk. That disk is maybe removed from a server or from a desktop. It needs to be plugged in. So most field kits will have, or even lab kits will have all kinds of connectors. So just be aware of what they are. Creating clusters. Clusters is really the smallest unit. Think of it as sort of the block size or cluster size. And that is what we see. That's where data is written to. There's information in each cluster too, like metadata. So keep that in mind. Biggest one is, of course, master boot record. And then one thing that's going to hold is a partition table. That's probably pretty important. If you're not, of course, the boot record is, the system does not, the image does not boot. It could be a bad boot record. It might be hard to repair, but you can at least see the partitions. And you might be able to find those partitions and use that information to pull out things like user areas and ignore some of the areas you may not need to look at. So, structure of a master boot record. I think I mentioned this before in the other video. 512 bytes, not very big. You really have room for 4 16-byte entries in IBM partition TeamScape. So there's usually 4 partitions. Normally the last partition is considered an extended partition, and then everything else is a logical partition. So these are actual physical partitions. So there could be a partition further written out. So the newer ones use something called a GUID partition table, or GPT. Those have room for all the partitions. So you have up to 120 partitions. So there's no need for an extended partition. This is probably going to be found in more, of course, the UEFI, the more modern BIOS. But it could be possible that you have evidence that is on an older system that uses the old BIOS, legacy BIOS, and has the old partition tables in place. So, and understanding, reading this master boot record, understanding what the hard drive is what a lot of these tools will do for you. But now you know how important it is to understand this concept here. So, boot process, cold boot, warm boot, pretty straightforward. We start the operating system. Now, it is possible if you want to boot off maybe a forensics thumb drive, you need to understand the BIOS or the UEFI and the boot orders. So, so that's something you want to look at. Again, really, it's the biggest rule is you do not use the hard drive, of the suspect unless an extreme case happens where you have no other reason. There are some bootable based tools you can use to help you make an image of that, or at least even investigate it. Hopefully you should not have to do that. Always keep that intact. But understand the boot process. I'm not going to go through all the detail here, but this is a really good breakout flow here. How Windows has the boot manager and then the WinLoader, and then the big boot configuration database. Now Windows is pretty straightforward. Typically you have one operating system for Windows. But understand how it reads that and finds the operating system. And there's a UEFI loader right there too. So, of course, the boot order again, initialization, sort of a BIOS, power on, self-test, post, and then of course the BIOS will check things like hardware. It'll look, hey, this is a low level initialization. Hey, I'll say, hey, memory, you there? CPU, you there? It's not going to boot unless it has the proper memory, CPU, and any other things it needs to check for. Okay, I have in my BIOS or UEFI boot order, I have any kind of plugged in bootable thumb drives. Okay, I don't see nothing. All right, we go to the disk I have on record, and I'll look for that disk, and I find a master boot record. Okay, I'm going to read that boot record. I'm going to load that boot. Now, if you're looking at a UEFI, it's possible that it's going to have a certificate for the operating system. That's real common with UEFI. It has a low layer of protection. It might read that certificate, be able to ensure the operating system matches what it expects to see. It might not. So it depends on the UEFI or BIOS settings. And then, so it uses 2 phases here. We have what's called phase 1, where we load basically a init version or a kernel. It's a small small version of Windows that loads Windows, and it transfers over to the actual full kernel of Windows. And so it loads that up, and then it goes into user mode. And that's where, of course, we have your desktop and all services are running. So Mac, so Mac bootloader, OS load. Again, there's your drivers. It's a little different because the Mac is baked in with the hardware. So realize there's some boot code, and there's the OS loader, there. As in all these operating systems, actually a lot of them, there's going to probably be a recovery sector and a recovery operating system. Mac has it, Windows has it. Linux might not have it. It depends. So realize that could be part of the process here. And Linux is Linux. Again, Linux, we have basically same thing, BIOS, post. It's all good. It looks for the master boot record. It finds the first entry for anything in the boot record that has a bootloader, and it loads that kernel, and then it mounts. So again, we have like a stage 1, stage 2, stage 1 here, stage 2 here. So, all right, I want to move on here so we can do some demo here. Windows file systems, the FAT file system. So this is an older file system, but FAT32 might still be found. You'll find these on, of course, thumb drives, things like that. A lot of times they come from the factory with FAT32. Pretty much can be read by Linux, by Mac, but it has some limitations. But understand the file structure. Chances are you'll need to see FAT16 or FAT12. You see there's cluster limits for those. And understand the file system layout. This is pretty important where you can find files at. That's going to help you dictate the files, and also where the data is for the files. Now, if the data is small enough to fit in the data area, it will be it will actually keep everything local. So, but also understands how this writes to their cluster. So going back to our hard drive, if it's so large, if it's small, and we'll need to fill up the space. So let's say this file's really small. We have a 2048 bytes, we have a 1024, or in this case 1034 size, and cluster 6 here you can see for Gary. Let's put some drawing on here. So here's our Gary.txt, very small. It's on cluster 6, and so it doesn't need all of it. So it has to fill up this space. This is called slack space. A lot of times it's just read from chunks from memory sometimes. But it depends on the operating system. So let's keep that in mind. It's been slack space. This is known to be, that'd be useful, but you'll find garbage here really. So if you try to read this entire sector, you should find the end of the file. Hopefully, it was a .txt file. So we're going to get into file structures here in a little bit. But you can see the file allocation table, how it's laid out for the FAT area. Let me go ahead and erase that and shut that off. Okay. The partition, the boot sector also is readable here too. Now this goes into, I have this broken out in a different video, so I don't get too much in depth here. But FAT partition does have a boot sector you can read for FAT file systems, for x86 older systems. So, I'm not gonna. I'll leave it here. There's a whole video. I can really dig into this, how to read this boot sector, which is like right down here. This actual boot partition entry, how it's read. Directory clusters here, cluster chain. So again, not all files fit in one cluster. They need to be rewritten to several clusters or blocks. I always say blocks, use of the Linux side of it. So realize how that's done here, and it's possible if you need to do that level of recovery. That's really low level. It's an important aspect to know. Also, file names and FAT volumes. You have, of course, a short entry and long entry, as I'm going to show you. The old school was the 8.3, but you can see the metadata that goes with a file entry. Second long entries, first long entries. So we got some spaces here. Checksums are important. Checksums are almost like ways to verify the previous bit of data. So it's for integrity. And file size, file cluster, create time. That's an important aspect right there, create time. Of course, it's for evidence. When a file was created, it can be of a huge deal. So NTFS, a little more robust. This is what you're going to see now. A lot more metadata, a lot more advanced structures, really because of reliability and integrity. So biggest one here, of course, is the MFT, the master file table. It's a huge one to be able to make sure you understand. But the bitmap will also continue. The entire volume will be contained in the bitmap, information about that, the bootstrap system/boot. So you have this dollar attribute name in the file system. So boot sectors, a lot longer. And you can see there's a GPT for the master boot record identifier here. So a lot of information is, of course, held inside here. And this is the same thing as a FAT. It just we have more information with the bootstrap code, for example. Cluster size NTFS, again, it could be 512, 2048. I believe 2040 is probably the common one, but the reading should give you that. But realize, again, you might see different cluster sizes. And this could, of course, be based on a custom partitioning for any reason. So NTFS does have a master file table. A lot more information inside there because there's a lot more stuff with records and a lot more overhead. So you can see here, master file table's got a lot of information for that. There are copies of this also made there. Again, with any joining file system, there's a lot of redundancy in place. Encrypted file systems, so I'm not going to leave too much here. Realize that a lot of stuff is encrypted. And of course, if you don't have the keys, you're not going to be able to read it. Those keys are usually tied to a login. Those can be tied to a password. So this is why the previous one we talk about if a system is on or off, how do you approach that? So this is sort of one of the big reasons why. Linux, big with Linux, user space, kernel space, two areas, but also the biggest one, of course, is the inode and the directory cache, especially inodes. So a couple also things too is with Windows, it's pretty much there's /Windows, System32, a couple of areas you look at. Linux is broken out a lot more different directories, and these, of course, can be on different partitions, which is very common. So, of course, you have / for root, but there's this sort of file system hierarchy standard. Some of these are virtual. So look at like the proc, for example, is a virtual file system. Yeah, proc is virtual. Very handy though. One of the biggest ones you'll probably look for this is /home. If you're looking for a user's save files, but there's also maybe if the root user could be a suspect, or its information could be here in root /root. I know we have the root directory by / and then /root. So we have two home directories though. So that could be information that could be handy if you know you're going to analyze a Linux system. Linux works off something called there's several types: RiserFS, HFS, but extended extended file systems. This is the older ones, ext2. Again, journaling is something that's mentioned. ext4 specifically, ZFS, XFS have journaling. NTFS is not Linux, but it does have journaling also. ext4 is one of the common ones you might run across. Again, there's a lot more ways to recover files and partitions. Look at the ext information. Again, we're looking at the inodes are very important. So the metadata, that's the inode table there. Information about the about the data block, and the super block and things like that. So Mac, really similar to Linux. APFS, HFS. As long as you built out the Unix file systems, the Berkeley FFS. Again, Mac is a sort of a derivative of BSD Unix. So you're going to find a lot of the same stuff will be in Mac as well as Linux. So again, we get the user space is a little different, but there is a hierarchy file system plus HFS plus. Again, these all have different advantages, disadvantages. So journaling, again, big one here. So we're going to move on here. I understand about character coding and ASCII, how stuff is character, ASCII table. And this goes back to hexadecimal and Unicode. There's a whole video on this. This is a huge thing to understand what hexadecimal looks like. Something you might run into. So anyways, the last part is file analysis for this chapter. I'm just going to demo this, but files have something called file headers. which is usually the first like 4 to 6 bytes of the file itself. And it's a good way to go ahead and figure stuff out. So a lot of information inside here. I'm at 20 minutes here already. So let's go ahead and look at a quick demo here. One of the biggest things this week, of course, is you look at Autopsy. Now I have it installed. I've already actually attached a image IMG file, which is a copy of a hard drive, Linux evidence. And you can see here's that Linux file structure. So off the bat, I know I can go to Home, Roger. So I know what home directory is that. I can probably go to Documents. And if I need to look for evidence, I can find it here. This will find deleted files because this is going through and find things that are marked as deleted. The chapter will talk about how when you delete a file, normally it doesn't delete the actual file unless it's securely deleted. It deletes the entry of the partition table, so the file's still out there. So you can see this finds things like metadata for files, but here you see extension mismatch detected. Now this is what we're talking about here. This is great. So plug in this images.txt file here. You can see it's not a text file, it's actually an image file. So what we have here is the FFD8FFE0. This is the JPEG file header. So let me zoom in here a little bit. FFD8. So now we know how something like Autopsy finds it and finds deleted files for you. It knows file structures. This does the heavy lifting for you. So if you feel like you're cheating when using this, you're probably doing it right. Autopsy is fantastic. It's free. It runs on Windows. Fantastic, actually. There is a Linux version, I believe. I'm not sure if it's one for Mac or not. So, but this is actually a really great tool for being a free tool. But you can see here FFD8. This is not actually a text file. So, as well as you'll go to the lab and look at ways you can use this. You'll parse out email addresses. This is using something called regex. This is regular expressions, and it's going to say, hey, here's all the things I found using this regex string. These are the different email addresses I found in this attached image. So, fantastic tool. I can't say any much more. I mean, file types. I want to look for by extension. Looking for documents, maybe PDFs. Great stuff here. So deleted files. If something's been marked as deleted, again, it's still in the system. Now it may be recoverable, it may not be recoverable. It depends on how long it's been on the system, and if any of the data has been overwritten by other files. But it's possible to recover these files, and that's actually something you do with a different app, I believe, a different piece of forensics tool. You do that during this lab. So anyways, important thing to look at here is, let's say we're looking at certain documents, PDFs. So here's top secret PDF, file metadata. There's access times, things pulled already from the inode. So here we see you might see the word inode mentioned. I know it's really tiny text. Right there, inode. So now you know what the inode means. It means the sleuth kit went in, did a deep dive. It found the access mode. Of course, its file type, and all its information about its data, about access time, created time. This is fantastic evidence. So there are times it might actually be able to find. Let's look at images again here. So let's see here. Sometimes it actually will go ahead and calculate out. In this case, it's not calculated. It might calculate the MD5 for you. Again, this is a hash. Hashes are fantastic. If it does that, then you have it already done. It depends if the hash has been done here. We can probably see if there is a hash here. Sort by hash. Click sort twice. We'll let that run. So a big thing is there's a lot of resources where you can find these file header types here. And while that's sorting, there we go. So some of these actually did find and calculate a hash for us. So here's MD5 hash. This is a big deal. I can't say it's enough. When you're the hash of the evidence, the file, where it was found, all this metadata about it, when it was created, when it was changed, this is so important. Again, I'm pulling this from a copy of an evidence file, which uses a hash to verify it matches. So we know this is a real file. But again, if this file gets given to defense, and they go to show that it doesn't match what we have, we can say, well, your MD5 doesn't match, and ours came from the evidence. You have a wrong file, or whatever. You can show mismatches there. So this is a huge thing. MD5 is just one of them. There's SHA, and other ones which we talked about in the previous lecture. So those are really important. So, and then other ones has WinHex. WinHex is a really great tool. This is a very powerful tool, actually. It sounds like it'd be the hex editor. This thing will actually create images. It'll back up stuff. It'll extract things like that. For now, though, again, we can open up a file here. So we have a file here on our desktop called file1.txt. I could open it. It doesn't look like a text file. It doesn't look right. So if I need to manually do it, I can go in here and look at the file itself. And again, the first 2 bytes here, right off the bat, tells me it is a JPEG file. Usually it's FFD8 E0, but it depends on where you look it up. This reference document here shows it, just the first 2 FFD8, with FFD9 being the trailer, hence should be the end of the file, FFD9. So you might need to use this tool for various reasons to find mismatches. But again, you can see how, oops, let that thing scroll. You can see how Autopsy works. If it says I found a file mismatch, it can read that header and look at the extension and goes, this doesn't match. And those, of course, could be suspect, right? Because maybe someone's trying to hide something. To the layman, you try to open it, you say it's corrupt. Word says it's corrupt. Can't open this Word document. You must think it's bad. But I know you can take a deeper dive and you can look into it without having, of course, launch Autopsy, simple hex editor. And I think we also have hex editor built into here. So let's go ahead and copy a file over, and we'll just grab evidence files here. Come on, give me. There we go. And we'll grab an image file, and whatever this thing is, we'll grab it. And we'll copy this to our home directory. Should be pretty quick. All right. I am in home directory /home. So there's your, if I can type correctly. There's the image file. We got hex dump. I think we do -C, I believe. Yep, there we go. And let's go and do that again. Now we can actually we don't need to do it again. We can just scroll up. There are, of course, other hex editors you can use, ones that are almost like WinHex. But if you want to, you can. Let's see if it fits in the. There we go. Again, there's our FFD8. FFD0, there's our file header. We know it's JPEG, and in case we ever need to find the end of the file, we know the file ending is the FFD9, and that is the file trailer. So, and that shows the end of it. So the rest of this, of course, is data, metadata about that. And if you look at hexadecimal or a binary file, such as this, you can sometimes see metadata. Might be up here, but most of the time, I think in JPEGs, there's not too much here. But some files will actually give the data, and you can pull information out from data from a file on. I know definitely on. I don't know if you have strings installed or not. I don't think you have strings. Strings, st. It does. All right. Strings, and that will pull out any ASCII strings from a binary file. Now, it doesn't mean they're going to make any sense, but it depends on the file. You might be able to extract, if the file is like a Word document, there could be some information about the file itself. So Just a little tip there. It's not in the book, I don't believe. So, anyways, that is it. That covers a little demo what you look at during the lab. Again, there's a lot of information in this chapter. I go deeper dive into a separate video. If you want to watch that, it's optional. You can. But this sort of covers what this module or topic talks about. Hope this was helpful, and thank you for watching.